next we have the displacement reaction. So displacement reaction, a more reactive metal will displace the less reactive metal from salt solution. Okay, so in this example, I have zinc in copper sulfate solution. So copper sulfate is my blue solution. I dip a metal piece, zinc metal. So zinc plus CuSO4. Okay, so zinc is more reactive. So more reactive can kick out the less reactive. Okay, okay, instead of kick out, we have to use the word displace, right? So zinc, word for word, right? When you write it, right? Explanation is over here. Zinc is more reactive than copper. It will displace copper from copper sulfate solution to form zinc sulfate and copper. So write the equation, right? This one, when it kicks it out, I got my copper, and then my zinc will partner the sulfate, right? So write out the equation, and then you can see what exactly happened, okay? The explanation and all that, right? So to know what will happen, my zinc, okay, it will dissolve or it will decrease in size. Zinc decreases in size. Okay, so observation, if they say what will we see? Zinc decreases in size. Blue copper sulfate, your qualitative analysis, you have to know blue copper sulfate turns ZnSO4, it decolorized. Zinc sulfate got no color. And then copper comes out as a solid. My copper is a pink or red brown solid. Okay, so please know, right, metals, the colors, they are generally gray. Okay, all metals are grayish in color, except silver is silver, gold is gold, and copper, we will have red brown or pink, depending on your school. Okay, so generally they will ask, right? Explanation over here, this will be the explanation with the equation, and then this is what we write for the observation. Okay, in another example, if I have silver plus silver, which is Ag, plus copper sulfate. Okay, so I know my silver is less reactive than copper sulfate, so there is no reaction. Okay, when the question say what do we observe in the reaction? Okay, please never write no reaction. No reaction is not an observation. Okay, never write this. Okay, never write what do we observe. Don't write no reaction. Okay, what we have to write is blue copper sulfate remains. Okay, no observable change. Okay, no observable change because they ask what do we observe. Okay, so this is a displacement reaction. We use the word displace when the more reactive can kick it out. Word for word, the kick out the less reactive metal in the solution. Okay, next one, right? If it is, for example, a metal, like metal plus a metal oxide reaction, right? So this one, because it's not a solution, right, we don't say displace, we say reduce. So remember, metals are reducing agent. Okay, so same thing, zinc and copper. Let me see what is this question asking. Yeah, so there is zinc oxide, zinc powder, and copper oxide. Okay, so I'm trying to burn this magnesium ribbon. Don't confuse, right? This magnesium ribbon serves as a fuse, okay, to provide energy. Okay, because you know this one is a solution. Reaction can take place spontaneously, right? But when it is a metal oxide, right, I have to give a large amount of energy, then the reduction can take place. Okay, so still this reaction is zinc with copper oxide, right? And then same thing, zinc plus CuO. So zinc is more reactive than copper. Zinc can reduce copper oxide from copper oxide. Zinc can reduce copper oxide to form copper plus zinc oxide. Okay, so I will get Cu plus ZnO. Okay, repeat myself. Zinc is more reactive than copper, so it will reduce. Okay, it will kick the copper out. So my copper come out and it will bond with the oxygen, okay, to form zinc oxide. Okay, so zinc is more reactive than copper. It will reduce copper oxide to copper and it is oxidized to zinc oxide. Okay, and then this is the equation. If they say what will we see? We will see red-brown solids form. Okay, and then my zinc oxide is white. When I heat it, it's yellow, and then when I cool it down, it's white. Okay,